Welcome back. We're going to do a simulation with an Arduino and show you how to build a high-speed flash using a 10-watt LED and an N-channel power MOSFET. So to get this thing up and running, we're going to use a breadboard. We're going to use our Arduino, and we're going to use some other circuits here. We're going to bring a We're going to bring a 9-volt battery in. We are going to bring a couple of resistors in. We'll use probably a few of those. We'll throw an LED in there. And we will throw a light bulb in there once we can find one here. We have to go click on this screen to say components all, and then we can come down here to let's see, power MOSFET. We want an N-channel transistor MOSFET. We'll use that one. And then we're going to do, we're still looking for a light bulb. Find a light bulb here somewhere. There's a light bulb. So the wiring here is really kind of a mess. There's really no way around it. There's just not enough real estate for everything that you need to do. So I'm going to try to make all the magic happen here so you can see what's going on. So the first thing is we're going to take some of these resistors and we will put them in the breadboard. And then we'll give them some values. So this one here is going to be a resistor number 1, and it's going to be 330 ohm resistor because we're going to put it on an LED. Here's our LED. This is, by the way, is a positive side of the LED, and we're going to bring it down to here. This will be our logic. I'm going to put this logic right here on pin 13, and pin 13 is going to be just like in our circuit. It's going to, there's a built-on LED on the Arduino itself, so we'll be able to see that. This side of it is going to go to ground. I'm going to put ground there. I'm going to attach this ground. Let's bring it down here to this. Let's take this positive here, bring it down to here. And we really want to keep some notations here. Let's have everything that is positive be red. Everything that is ground be black, and everything that's logic have some other color. Let's have this one be pink. And this resistor here is going to be a 10K resistor because it's going to be a pull down resistor. It's going to keep that logic pin from floating. The logic pin that this is going to be attached to is going to be on this side, and we're going to put it on pin 5 just because it's going to be a nice place to put it. I don't want it green. I'm going to take some other color. How about orange? And I'm going to attach this side of the resistor to ground. There's the ground. And this keeps this pin here. It won't float this way. And since that's the ground one, I'm going to turn it black. And that's just sort of good housekeeping skills. There is the power MOSFET, and there's the light bulb. I'm going to rotate the light bulb using this little guy here. So it's just sort of sideways, and I hope it goes together and makes kind of a nice arrangement. Here's the logic, which goes to the gate. I'm also going to have this, I might as well be orange because it is logic and it connects to this logic. The center one here, I'm going to be going to my light, which is there. The rest of my light is going to go to the positive terminal, which is here. And then my last part of this, by the way, these are positives. So let's make those red. There's red. This is also going to go to the positive side. So there's, come on, red. This is going to be the negative side. And I'm going to kind of do this. We can do these weird clicks and we can go around everything. So it's okay if it's green. Green is good for ground, but let's turn this one black for ground here. So that's set up there. Now the next thing we need is a variable resistor, which is our potentiometer. And our potentiometer is right here. The way that this potentiometer is going to work, I'm going to also turn this potentiometer all the way around. And I'm going to have the center one be our wiper, and that's going to go to A3. I'm going to go do something like this. There's A3. And since this is analog, I'm going to turn that to something that maybe is analog, like a blue or something like that, just so we can see that it's different. One side of this is going to go to ground. So here's my first terminal. I'm going to put that to ground. Since it's black, I'm going to ground is black in our notation. And this next one here is going to be the other side of that potentiometer. And I'm going to take it over to here and put it to 5 volts, which is there. And since it's 5 volts, it's going to be red. Now, this board here is all floating. We don't have it attached to the ground like I really like to. So I'm going to now put some wires on it. There's a ground wire. I'm going to come out of here, go over here, go up to that one, and change this one black because it's going to be our ground wire. This is the red, so I'm going to bring this one, I'll bring this one here, down over here to this terminal. Actually, let's bring it over here, and we'll put it right here on this 5 volts. So you can see that it goes to that 5 volts without getting confused with that potentiometer. So that's going to be red. So that's our circuit, and hopefully everything is going to work once we bring the code in. So let's see how we do that. So over here, we're going to say code, and I'm going to get out of this this text code here and just put in. I'm going to get out of the blocks and put in text, and it gives me all sorts of warnings. There's the beginning of the text. On the other side here, if I minimize this screen, I have typed out a lot of code here, and actually let's type it out together and figure out how it all works. So I'm going to stop this. We're going to stop the record, I think. Stop video. We're going to go here. And we're going to start video. And hopefully we're back. So I'm going to write this code in the Arduino program. So here's the Arduino. I'm going to take this little picture window and put it over here. And we want to make sure we give it a name. So we're going to start with the name and some comments. Analog input 2020.ino for the code here. And I typically give a bunch of descriptions of how it works, but I'm going to be kind of shorthanded and I'm just going to leave the comments out about how to run the code here. I'll also put a copy of this code on the MyShares upload, so you can check it as you go through it. We're going to define some stuff here. Our first thing that we're going to define is an LED. And that LED is going to be on pin 13. So all I have to do is say 13, and of course, LED on pin 13. Next thing I was going to say, I'm going to use an integer, and this integer is going to be the on time. And the second integer is going to be the off time. And these will be read from the analog input, and I'll show you how to do that in a few minutes here. The next thing, we're going to have a constant integer, and this constant integer is going to be the analog pin where the signal is going to come in from, and that's going to be pin 3. This is the variable, the pin that's going to read the variable resistor. Also, we're going to have a constant integer for the high-speed flash, and that's going to be on pin 5. And this will be the pin for LED. Of course, it's the 10-watt super bright LED, and it will also control the power MOSFET. By the way, the power MOSFET that we're using is an N-channel, and the N-channel power MOSFET is a 3-0, that's 0, N06L N-channel power MOSFET, which is a pretty nice little piece of equipment. So the next thing on our list is we're going to have an integer, and then we're just going to call this value, a val. And this is a variable to store the value read from a 3 pin. And that's about it on those. Let's get into the void setup system here. I'm going to get rid of this statement, which by now we're pretty used to this stuff, and we know that the void setup is a setup. So we're going to say pin mode. Our first pin mode is going to be the LED, and of course it's an output. And the next pin mode is our high-speed flash, and that's also an output. And what would a program be without a serial input, a serial output? We're going to send some of these values to the serial port, so we know what they are. Serial.begin, and I'm going to tell the port to be at 9600 baud. And so that's that part. Now we're going to come down here to the void loop, which is where the meat of this program is going to be. And it's really kind of a very short, sweet little program, but you can do a lot of stuff with this. So the first thing that it's going to do is it's going to say value is going to read the analog read this analog pin. And this will read what the value is coming from the analog pin. Reads number 0 to 1023 values. Resistor. And now we're going to put some of those values together and see what they say and show them on the screen. So I'll say serial dot print. And that serial, well, we're just going to start having it say some stuff. Analog value equals something. By the way, those need to be all in parentheses. And close that parentheses, close that line. I'm going to use serial print a whole bunch here, so I'm just going to copy it down. Next serial print is going to be what that value is. Value. Close that line. Let's put some units there. So serial print is going to have some units of microseconds. Microseconds. And we'll close that off, close the line. Now we're going to read that value. So now we're going to say on time. This is that on time for the flash. This on time is going to equal the value that's read from the pin, and I'm just divide by 3. So that takes it from, say, the maximum is 1023, and I divide by 3. So that's around 333 microseconds, which is a pretty slow flash. But you know, we're learning here. So this flash actually, because of these are full values here, it'll go from 1 microsecond up to probably 330 microseconds as we go through everything. So that's that little line. Remember, if we want to change that on time, we'll have to change it from an integer to something like another value with a lot more accuracy to it. So the next thing we're going to do is another serial print, and this is going to be flash on time, and I'm going to say something like equals. Oh man, I left my parentheses out. And then serial print again, we're going to print the on time value. And then let's put some units behind that. But since this is the last one, we're going to say line return. And this is going to have some units of microseconds. We'll cover that up, cover that. And that should be enough to let me know what exactly is going on with those values. So here we go. Here's the meat of the program. I'm going to say digital write. High-speed flash, high. And of course, this will turn on LED. The next part, I'm going to say digital write. LED high. This is that red LED that's just going to follow. So I can see if the flash isn't working, I can look on the board and see that there's a little red light blinking, and then I have to go and see what's going on with that N-channel power MOSFET if I've messed up the circuit or not wired correctly. The next thing I'm going to say is delay. What am I going to delay here? I'm going to delay a time, and I'm going to say 1,000 minus the on time. And that's the reason for that is I can define what the on time is, and then it's going to go once a second. I could just have it on and off for the same amount of time, and that might be kind of cool. So let's do that, and let's keep that delay just as the on time, even though it's not really this is actually really the on time, but I want to have another delay in there too. So that might be a little confusing. The next thing I'm going to say is digital write. I'm going to take these two chunks of code right here, bring them down again, and I'm going to turn them off. So this is my flash low. It'll turn everything off. This will turn everything off here. And we're going to say another delay. And this is where this delay on time kind of gets tricky. You're going to have to write and modify the code, so it probably makes a little bit more sense. So this is the delay time, and the on time and the delay time are the same. So you're going to have to think, how do I change that? How do I have some variables that'll make this work better? So I'm going to verify this. Hopefully I haven't made any mistakes. I'm going to just save it somewhere. It verifies okay. It says that there's no Arduino attached at the moment. And I'm going to take this code here and I'm going to copy it all. And I'm going to go over to that, this guy, my Tinkercad program, and I'm going to paste it in. Now, if everything is right, we're going to start the simulation, and we should see stuff starting to blink correctly. And if we don't, something's not hooked up right. So, oh yeah, we do have some problems. We're going to stop that simulation, and we have a floating pin here. So I'm going to take this this pin here, and I'm going to come over here to ground because my grounds aren't all connected. Come on, attach that. And it's a green. I'm going to call it black because it is ground. And I'm going to start that simulation again. And there it is. It works. So moral of the story is don't have any wandering ground pins, and make sure you can get this piece of code up and running. And you've learned a little bit about N-channel power MOSFETs, as well as a little bit about code. I'll give you an assignment, and hopefully you guys have had a good weekend and ready to go.